right, welcome back. This is Vodcast 5B
Right.
for chemistry, ionic bonding. This is Coach Forster. I'm Coach Arthur. We'll look today at how to write the names and formulas of these ionic compounds. So important stuff right here for you guys to learn. Ionic compounds, they have two-word names, Coach Forster, depending on what atoms or what ions make up these. The first word is very easy in writing this name. It's just you're just writing the name of the first ion. If it's sodium, it's sodium. If it's aluminum, it's aluminum. There's nothing special you do to the first name. The second word, you can always remember to do what?
Change the ending to IDE.
IDE. So if it's chlorine, you make it
chloride, and
oxygen becomes
oxide.
Okay,
so it's not really changing the word at all. I'm just changing the is it the suffix? Is that it?
I think so.
That's what it is. The suffix.
Cross-curricular.
Changing the suffix. All right. So what's the first word here?
First word here is going to be sodium.
Sodium. And then the next.
So oxygen would become
oxide.
Oxide. Change the ending to
sodium
IE.
oxide.
Okay, calcium.
And then we have calcium.
Chloride.
Right, changing the ending there. And then we have potassium. Potassium.
And bromine becomes
bromide. All right, so pretty simple here. You
it's
guys
pretty simple. We'll let them fill out the
we'll let you guys fill out the rest of these here. So it's not.
But again, Coach Forster, we're not worrying any here about the numbers.
Nope.
Okay, that's all.
Nope.
We're going to worry about those when we go the other way. When they give us a name and we write the formula. But the naming is pretty simple. Just remember to add that IDE at the end. So do you want to go about writing them from the name?
Yes. If I have an ionic compound, for example, potassium sulfate, how do I know what the formula is? Okay, so we're going to talk a little bit about this word over here a little bit later, because that's a little bit another thing about ionic compounds. But remember, the compound must be neutral. So those positives and negatives have to equal out to give me a neutral compound. So I have one potassium, and remember from last test.
It's in column number 1.
Yeah, right. Last vodcast, it will lose 1 electron.
So it's +1.
So potassium will be a +1. I have a sulfate, which is called a polyatomic ion. Okay, so
which is just two elements, two nonmetals.
Right, two nonmetals put together. And they always have pretty much negative charges. There's one with a positive charge, but they're always going to be negative usually. And it has a charge of -2. Therefore, I need, to get that neutral, I need 2 potassium ions. Okay, because if I have a +1 and another +1, that gives me a total of a +2, which will cancel out my -2. Okay, so I'm always looking for a way to make these neutral.
So in your formula, you have K2.
Right.
SO4. Now let's put that SO4 in parentheses, because this is something good to know for you guys, is that SO4 is a polyatomic ion. And we're going to give you a chart called the polyatomic ion chart. We don't ever change the formula of SO4.
Right.
You're not going to change that 4. Okay? It's almost as if it's its own thing that I can't change.
Right, it's a unit.
If I were adding a subscript to that, in this case I'm not. But if I were, it would go outside the parentheses.
Right, down here.
Because we're adding it to the whole thing. Okay?
Right.
And we'll do some more practice on that.
Yes.
As we go. So here's an example of an easy way to figure these out if they get a little tougher. Sometimes they'll be tougher. And you may have, like in this case, aluminum is in the column labeled +3. Oxygen is in the column labeled -2. Well, you could spend some time doing the math there and figure out what do I need to make them each. But we've got this method right here called the crisscross method.
Right.
That if you take that 3 from aluminum and put it down below oxygen as its subscript, and the 2 from oxygen down below aluminum as its subscript. Well, now let's look at this, Coach Forster. You've got +3 times 2. You have 2 atoms at +3. That equals +6. And then you've got 3 atoms of oxygen at -2. What does that equal?
That equals -6.
-6. So there we've got a neutral compound. Okay. So we didn't have to do a whole lot of work, just to crisscross, and we had a valid formula.
A valid formula written.
Okay, so let's practice writing some of these.
Okay, so help me out back there on the table, Coach Arthur. I think I have them labeled. Sodium is Na.
Sodium is +1.
And it has a +1 charge.
And chlorine is -1.
-1.
And let's just make sure as we write these,
Mm-hmm.
our charges don't really go in our final answer.
Right.
Okay, our charges just help us get to our final answer.
Mm-hmm.
Okay.
So I'm going to do the crisscross method. A 1 down here and a 1 down here. All right. In a formula, though, we really don't have to write the ones.
Ones are understood.
Understood because I wrote the compound there. Okay, or I wrote the element there. So it just could be NaCl, your final answer there.
Okay.
And now calcium, which is
Calcium's +2.
+2. And then sulfur
is
-2.
-2.
Remember, it's not going to look like sulfur. It's going to be sulfide, but I just know that I added an IDE ending.
Sulfur is -2.
All right, so this 2 will go down there. That 2 would go down there. So it'll be Ca2S2. All right. However, Coach Arthur, when we have something that's both divisible or has a common denominator, no, yes. So I can divide both of those by 2, and I can get CaS.
So there's no need for subscripts
unless they can't be simplified down to something simple.
Yeah. Okay, barium +2.
+2.
Fluorine is -1.
-1 came from the element fluorine. Now it's fluoride. So I'm using the crisscross method. This 2 will go down here. That 1 will go down there. So it'll be BAF2. Okay. And we'll kind of leave you to do these last 2 here, aluminum oxide and magnesium phosphide. But you see, as long as you use the crisscross method, you'll never be wrong.
You'll be okay. Mm-hmm. All right. Well, that's it.
Yep, that's it. We'll do some practice in class about writing compounds, and we'll kind of explain a little bit more about polyatomics next time.
All right.
All right.
See you.
See ya.